Okay, for number 21, the letter F is reflected in a mirror, so the image here should be, this one will be coming first. Okay, so this is the image that we will be getting here. So your answer here is B. Let us look at number 22. Okay, number 22, the sun emits infrared radiation and also light. Light from sun reaches the earth in 8 minutes. Which row gives correct information about the infrared radiation? So if you look at our EM, our electromagnet, so first we will have a radio, okay, a radio wave, then we will have a microwave, then we will have an infrared, okay, so this one I just make it in full, infrared, then we will have a visible light, okay, visible, I just make it light here, then we will have UV, X-ray and also gamma ray, okay. So now here you have an increasing in a frequency and decreasing in a wavelength. So here we will have the longest lambda, the wavelength, and here we will have the shortest wavelength here. So if you notice that light, they have a longer lambda, okay, longer lambda. Okay, so your answer here should be longer than a wavelength of light. Okay, so it should be A and B, A or B. If you look at the time taken, the speed of all the EM is the same, okay, which is 3 multiplied with 10 to the power of 8 meter per second. So it should be 8 minutes at the same time. So your answer here will be A. Okay, now we move to 23. So which statement about electromagnetic wave is not correct? So they travel at 3 multiplied with 10 to the power of 8 meter per second in vacuum. Yes, is correct. They transfer energy. So wave, they have to transfer the energy. That is their main objective of the wave, like sound wave, okay. So they travel at this is actually the speed of sound. The speed of sound in air, approximately 330 meter to 340 meter per second. Okay, so your answer here is C. And D is correct. They are all is a transverse wave. Okay, what is ultrasound? Our hearing frequency, human hearing frequency is 20 Hz to 20,000 Hz. So if it's ultrasound, it's beyond than a human's hearing range. So this is under frequency, okay, frequency. So should be higher pitch or lower pitch. Ultrasound should be a higher pitch. Loud we cannot, because this is an amplitude. To quiet and loud is more to amplitude. So we have to look at the frequency. Is a higher pitch or lower pitch? So if a beyond 20,000, it should be higher pitch. Okay, so your answer is boy over here. Okay, number 25. Which diagram shows the electric field pattern between two oppositely charged parallel metal plates? So if you're asking for two oppositely charged positive plate and also negative plate, so remember the charge will be going out from positive toward the negative. The arrow should be like this. If it's a circle, it should be going all the way around with the arrow going out of the sphere. Okay, so this is the pattern. If it's negative, it's coming back, coming toward the sphere. Toward the sphere. So your answer here is A. Okay, 26. Which circuit symbol represents a component used to measure electric current? This is ammeter. Okay, this is an ammeter. So should be A. ammeter. So 27, the graph shows current voltage characteristics of a conductor. Where on the graph can Ohm's law be applied to the conductor? Ohm's law must be a straight line. Okay, must be a straight line. V, I, or I, V. It doesn't matter, but have to be a straight line. So should be from here to here. It's a straight line between P to Q. Okay, that's your answer here. Okay, now we move on with question number 28. It looks complicated, so let us do this. 28. The diagram shows a circuit containing two resistors. This is 1 and 2 ohm. A voltmeter is connected across 1 ohm. Voltmeter is at 1 ohm, okay, by connecting P to X. P to X over here, okay. And then the reading of the voltmeter is 6. So when they are connected here, this is 6 voltage. P is moved to point Y. It's then moved to point here. Okay, now first let us calculate the current produced over here. Okay, because the current here will be the same. So V equals to IR. V is 6 over the resistance. Okay, 1. So the current here is about 6 ampere. So the 6 ampere current is also moving across the 2 ohm resistance. So we apply the same formula again. 6 and the resistance is 2, which will give you about 12 watt. So your answer here is C. C for, oh, sorry, this is a small error. This 12 is across the 2 ohm. So when they're asking the total P to Y, so which means the entire thing. So from here to here, so here is about 6 voltage and here is about 12 voltage. So the total here is about 18 voltage. Okay, the answer is D here. It's not C, D. There is a current I in a resistor. The potential difference across the resistor is V. Okay, which other physical quantity is needed to be able to determine the energy transferred by the resistor? So we have here the current I and also the V. So to measure the energy, when they're asking the energy, we need to have V, I and T. So we are missing this T. The time T for which there is a current in the resistance. Okay, so we need the time. Okay, number 30, the diagram shows pair of circuit containing logic gates. In which diagram does the lower circuit of the pair behave differently from the upper circuit? Behave differently, it means they are giving an opposite output. So should be here. This is not gate. This is 0, 1 or 1, 0. This is AND gate. So should be 0. So this is the AND gate's truth table. Okay, truth table A, B. This is the input. 0, 0, 0, 1, 1, 0. 1, 1. So your output here will be 0, 0, 0, 1. This is for AND gate. And for NOT gate, okay, this is AND gate. If you have a NAND gate is this one. You have a dot, you have a circle here. Okay, so it should be the opposite. 1, 1, 1, 0. Okay, now we move on with this. Okay, now we look at is there any OR? Okay, OR gate. For OR gate, truth table is ABX 00011011. So here you'll be getting 0111. For NOR gate, NOR gate is the thing that with the circle in front of the OR gate. So here you have 1000. Okay, so this is the truth table for the OR gate and also the NOR gate. So now when you have 0, so it means 0 at both sides. Okay, this is NAND gate. Okay, this is NAND gate. So we have to look at here. So it will behave 1, and if it is 1 here, okay, if it's 1, it will give you 0. So it behaves the same. And let us look at B. So here you will have NAND gate 2 times. So let's say we put here 0, you will have 1. If it's 1, you will have 0. So for NAND gate, let's say we just change to 1 0. Here we should get here 0. So if 1 0, we just look from here, you have to get 1, which means if 1 is 0. Okay, now we look at, so this is correct, it's the same. So now here this is OR gate. OR gate, we have to look at this. If it's 0 1, then you will have 1 here. So if it's 0 1, OR gate, NOR gate, you'll be getting, you just have to look at here. Here you'll be getting 0. If it's 0, look at here, this part, this one, you'll be getting here 1. So which means this is also the same. NAND gate. So if it's 0 1, you should be capable to get here 0. So now we try with the circuit below here. 0 1, we look back at here at this. So NOR gate, you are getting here 0, and here be getting 1, which is different, right? So your answer here is D. Okay, for number 31, several cells are connected in series as shown. What is the combined electromotive force EMF of the cells? So it will be sum of the EMF. So that is your best answer here, sum of the EMF. Example, now you have a 1.5, 1.5, 1.5 and 1.5 voltage. So you just have to times with 4 here, and total of this voltage is 6 watt. Okay, so this is the answer for number 31. Now let us continue with 32. Okay, 32. Two resistors with the resistance R1 and R2 are connected in parallel. The resistance R1 is greater than the resistance of R2. What is the resistance of the parallel combined? So it should be, okay, example, if let's say we have a doubt on this, we just have to make it like 6 ohm, and here's about 3 ohm. Then we do the calculation. Okay, so example, like 1 over 6, 1 over 3, 1 over R total. So here becomes 6, here's 2, 3 over 6. Then we change back. Okay, just invert this, you got 6 over 3, which will give you about 2 ohm. So if you look at it, it is lesser than both of these, right? So it's less than R1 and R2. Okay, now we move forward with number 33. The diagram shows a motor connected to an AC supply. The circuit is incomplete. Which device needs to be connected between the X and Y to prevent the wires from overheating, and if a fault in motor causes the current to get too high? So we have to put here a fuse fuse is a most cheapest protection method. Okay, fuse. So this is the fuse. Inside here you have a wire. If it's overheat, this wire will get disconnected and you won't have the current flowing. Okay, so this is for number 33. Okay, number 34. The diagram shows a wire between the two magnets. An electromotive force EMF is induced in the wire when it is moved up between the two magnets. Okay, 4 tests are done. Okay, this is induced current. Okay, you have direction of the movement reversed, direction of the magnetic field reversed, wire is moved more quickly, you have a higher, so this is same magnitude, and this one is higher magnitude. Okay, higher magnitude. The magnetic field strength is decreased, so which is the strength of the magnet is reduced. So this is you can say reduce, or you can say lower magnitude. Okay, all this stands for magnitude. So which test will induce a smaller EMF, smaller magnitude in the wire? So you can say your answer only 4, D. Okay, number 35. 4 portion of the current carrying coil in a magnetic field as in a DC motor is shown. Diagram 2 and 4. 2 and 4, the coil is at 45 degrees to the field line. Okay, so which row is correct? Turning effect of the force in the position of 1 and 3, it will be different, and turning effect of the force in position 2 and 4. So 1 and 3, okay, 1 and 3, so here you will have the maximum. Okay, this one is almost no turning force. Okay, there is no effect. It will turn around by inertia. Okay, so this one must be different. And the 2 and 4, since the angle is the same, right? So they should have the same turning force. So the answer is boy over here. Okay, 36. The diagram shows the magnetic field due to a current in a solenoid. The direction of the current is reversed. Direction of the current is reversed, so the magnitude here will remain unchanged, and the direction of the magnetic field here will also change. Okay, direction will be changed. So your answer here will be C, because they just changed the direction of the current, positive to negative, and then they change it to negative and positive. Okay, number 37. Okay, the nucleus of a americium atom contains 146 neutron, and this is 95 proton. It decays by emitting an alpha particle. How many neutrons and how many protons remain in the nucleus when this form of americium decays? Decay by emitting alpha particles. So we can place here, example, this is the americ. Okay, I'll just make it A here. So here's 95, and above here should be a nuclear number. So 146 plus with 95, so here you should get 241. The proton number, sorry, the neutron number here is 146. So here, when it decay, it will decay a particle 4,2 alpha. Okay, 4,2 alpha. So which is helium. So this is alpha. So the number here will be 93, and here we have to reduce to 4. So 214 minus with so you should be able to get here 27237. Okay, so this is what's supposed to get here. So proton is 93, and then your new neutron here will be 144. So this is your answer. So your answer is C. Okay, so this is your explanation for this. Okay, question number 38. A sample of americium decay and changed into newtonium. Half-life of americium is 432 years. Which fraction of the americium will remain after 1728 years? So we just have to divide this. So it's how many half-life is that? So this is about 4 half-life. Okay, so it's about 4 half-life, which means fraction. So you can say it's 100%. Then you divide it by 2. Maybe I can use a fraction method over here. Divided by 2, then divided by 2 again, then divided by the 2 again. So you have about 1/4, so which is about 50%, and it reduced to 28%, then it reduced to 12.5%. So 12.5% over 100, you'll be getting 1/8. Okay, so C is your answer. And C is not your answer, so this is wrong. So you know why? Because when you calculate this, you will be getting into a point form. You'll be getting into a, okay, this is 4 times. So this is 1, 2, 3, and you need another one more here, which is 4, 1/16. So it should be divided into half, 6.25. So this is not your answer. Your answer is supposed to be this. I'm very sorry, I never noticed this. Should be 4. Okay, should be 4. So your answer you should have here about 4 half-life. 1 half-life, second half-life, third half-life, and the fourth half-life. Okay, so 1/16. Okay, number 39, the graph shows a decay curve of 4 different radioactive isotopes. Which isotopes have a larger half-life? So if you look at here, this is the original. Okay, this is the original. So when they reduce to half, let's say this is the half of the original. This is NO, this is let me erase this. Okay, this is NO/2. So it's very short. This is very short. Okay, this is very short half-life. So if you look at, they're asking for the largest half-life here should be A, because it takes a long time for it to reach to the half. Okay, now we go to number 40. So the diagram shows alpha particle and beta particle passing through electric field. So okay, just remember this. Alpha is a positively charged. Okay, alpha is a 4,2 helium, it's a positively charged. It will be attracted to the negative plate. Negative. Beta is an electron, so it's a negative charge. It will be attracted to the positive charge. So this is wrong, and you can see this part. Beta, this is also wrong. Alpha here is also wrong. Okay, your answer should be, most possible answer is boy, because A, even though the direction is correct, but is still wrong, because the beta in his electron is very light. Okay, light in mass, little mass, but this is much more heavier. So supposedly let me show you here, that this is a positive charge and this is a negative charge. Okay, let me draw an alpha. So the green color is alpha, so it will be like this. Okay, but if you look at the beta, this is beta, it is very quick. So there is a difference in the angle here. This is a smaller angle and this is much more bigger angle. Okay, so your answer here will be boy. It is slightly attracted to the negative. So I hope you learned something in this video. Thank you for watching, and please like and please subscribe. Thank you.